after lunch, so we can all join, come together and listen to these great speakers. After the keynote speakers and the other talks, in that hall there are 1, 2, 3 more halls for the breakout sessions. If you're looking for them, you'll be welcome to join them. But I am going to shut up. All right. Sorry? There. Yeah. Because we have much greater people to talk than I am. And I tried to catch up with the guy yesterday during his wonderful presentation, Aikido. He's a master in doing presentations. He's a master in a lot of stuff that's Perl related. And I would say, give him a big welcome, Damian Conway.
Thank you. Good morning. Wow, it's great to be back here with all the European pearlmongers and the British. And as you probably know, I love Perl. Yeah. I love the Perl community. I love Perl 5. I love Perl 6. But love is a complicated emotion. Because as much as I love Perl 6, I also hate Perl 6. And the reason I hate Perl 6 is because of the way it makes me feel about Perl 5. And I'm not saying there's anything wrong with Perl 5. Perl 5 is a fantastic language. Perl 5 to me is the Liam Hemsworth of languages. So it's kind of capable, it's pretty powerful looking, it's workmanlike, doesn't look too bad. And then you meet its sibling. And so when I need to write some code, some object-oriented code, am I going to do it in Perl 6, where the whole class looks like this, and I have these lovely built-in keywords to declare the class, to declare the methods with typed parameters, where I have a has declarator, which declares the attributes of the class as simple variables, which you can then use in the methods without annoying lookups all the time? Or am I going to do it in Perl 5? And that's the exact equivalent in standard Perl 5. Now, of course, I'm not going to do that anymore because, that's just using the standard tools of Perl 5 in a kind of an odd way to get object orientation. And no one does that. We worked out long ago that the right way to do that is to get rid of all of that code that's not actually solving any problem for you except the problem that Perl 5 doesn't really have OO. And you get rid of that and you replace it with something like Moose. And now you get your kind of has declarator, but you don't get nice attribute variables, and you still have to do lookups to even get to the attributes. And you end up with still twice as much code, twice as hard to get it right, and runs half as fast. And that's why I hate Perl 6. Because Perl 6 makes Perl 5 feel like Perl 4. For those of you who don't know, that's the third Hemsworth brother. That's Luke. And you cannot tell me that he is not a host. So all I wanted in Perl 5 was 3 little words. Little words like Perl 6 has. I mean, like literally like Perl 6 has. And class. And method. So, being me, I thought, how hard could that be? Well, it turns out that it is harder than solving a 7-dimensional Rubik's dodecahedron, but it's not as hard as successfully rebooting the Fantastic Four franchise. So in other words, it's not really very hard at all. And how do you do that? You do that how we solve every single problem in every single language. You just need to add one extra level of indirection. So what did I do? I said, well, damn it, I'm just going to write my Perl 5 code as if it were Perl 6. I'm going to write a module, modestly called DOS, that will make that work. So how do you write a module that makes that work, that adds new keywords and new behaviour to Perl 5? And the answer is, that's been available for more than a decade. It was available in Perl 5.12 and later with the pluggable keyword mechanism. And if you dig deeply enough into the documentation, and frankly, they hid the documentation of this feature really, really well, probably for good reasons. When you dive down deep enough and find it, then what do you read? You simply implement new keywords in C. To which my reaction is, oh, hell no. So you go back to CPAN and you see that some kind soul, Lucas May in fact, has solved that problem for you with a module called Keyword Simple. You read its documentation and it says, you implement your new keywords in pure Perl. Ah, that's what I want. And how does this work? Well, you set up a callback that will be called any time that a keyword is encountered by the Perl 5 parser. And when that keyword is encountered, and it detects that you've set up a callback, it passes all of the remaining source code of your file to that callback, and then your callback just has to parse out the keyword's arguments, the parts that belong to the keyword, and replace those with some standard Perl 5 code that implements the same behaviour. And so that's exactly what I did. Here is the DOS source code, and that's exactly what you do. In your import subroutine, so every time you say use DOS, this happens. You call keyword simple's define function and tell it, I'm going to define a new keyword called method. And here is the callback for it. Just a regular old subroutine. So what do you do in the subroutine? Well, first of all, you accept that it's going to pass you a reference to the rest of your source code in this current file. And then you're going to have to parse out of that the bits that represent your method declaration. So you get a regex that represents some kind of identifier, and you say, well, I'm going to match that against the source code to find out what the name of the method is going to be. And that was easy. And then the rest goes horribly wrong. Because now I have to parse out any arbitrary list of Perl parameters and an arbitrary code block. And of course, years ago that would have been a huge problem, but it isn't now, because now we have PPI. How many people have heard of PPI, the module? This is an extraordinary module written by Adam Kennedy, another Australian, which explains pretty much all of it. And this module is able, in Perl itself, to parse most Perl programs. So what do? You say, make me a new PPI document from the trailing code, and you get back a parse tree that represents the structure of your remaining code. So you then go in and say, well, what I'm going to do is I'm going to walk through that tree. I'm going to take the first child of the first child, and I'm not going to explain to you why it's 2 levels deep. It just is. And I'm going to say, well, was that in fact a list? Was that the suitable list of the parameters? If it is, then I have my parameters. And if it's not, then I don't have any parameters, so I'm just going to set params to undef, and otherwise I'm going to remove that parameter list from the PPI tree. Why? Because then I'm going to go back and have a look at the first child again, which will now hopefully be my block of my method. but it might not be, because methods could also have Perl subroutine attributes on them. Is method, for example, column method, for example. So I'm just going to go through and I'm going to be looking until I find a block. I keep looking until I find the block, and eventually I find the block and I check that I did find a block. And if I found the block, then I've got all the information I need, because I've got the parameter list, and I've got the block, and I've got the name, and I know it's a method, and now all I have to do is rewrite that code to be a proper Perl subroutine. So I'm not going to bother to show you how you rewrite that code. You just call a subroutine that you've written, and you pass it the parameter list, and it works out how to write code to make those parameters be type checked and do everything else that they can do. And you take the block and you remove the outer curlies of it, because we're going to construct a new block, and then you literally construct a new block. You make a piece of code that says sub, and then the name of the subroutine, and then any attributes that might have been left behind, and then curly brackets with the parameter setup, followed by the original code of the block. And you append any remaining code that was in the file that you didn't need yourself, and you put it back into the variable that you were given in the first place. And that's how you do it. That's the way that you create a new keyword in pure Perl in Perl 5. Which is simultaneously awesome and sucks. It's awesome because we were able to create a new keyword. It sucks because the only bits of that code that are actually helping us create the keyword are those bits. And all the rest is just compensating for the problems of having to do this in pure Perl. And then you multiply that by the 3 keywords that I wanted, and you get this. 107 lines to implement those 3 keywords. 80% of it just infrastructure code. Code that's not solving my problem, except that my problem is Perl 5 doesn't have a better mechanism for this. So the only thing that I don't like about keyword simple is the name. I do not think that word means what you think it means. So I could have done that, but that's not me. When someone gives me a tool for building other tools, and that tool isn't sufficient, what do? I build a new tool for building tools. Except I don't do that anymore because that's too much work. It's much easier to go one level deeper and build a new tool for building tools that build tools. You just add one extra level of indirection. And that's what I did. You're going to love this. I used keyword simple to create a meta keyword, obviously. I said, I want a keyword that declares other keywords. Because, of course. So what am I going to call that? Well, I'm not very imaginative. I just decided I'd call it keyword. And what would I call the module that would construct this? Well, the obvious name was... But I thought, nah, that's going to be really hard to search for a start. So then I was going to call it this. But apparently only 4 people in the world know what that means. So in the end I just called it keyword declare, because you use it to declare other keywords. And the way it works is more or less like this. You use keyword declare and you get a keyword keyword. And you say, I'm going to use this to declare a new keyword. In this case, I'm going to create one called debug. And then you give it a parameter list with types, and those types tell it what to look for next. So debug is going to take an identifier followed by a block. And when it takes that and matches that, it's going to put those pieces of the source code into 2 variables. And then I'm going to use those 2 variables to create a string that is the replacement text. And I'm not going to mess around with putting it back into the original string and taking things out of the string. You're not going to have to worry about that anymore. That's all infrastructure. Instead, you're just going to return that new source code. And then instantly, you are going to have a debug keyword, which takes an identifier and a block. And that's what I did. So you're almost certainly asking yourself, well, okay, that's great, but how does the keyword do its keywording? And of course, it's just a wrapper around PPI simple, plus a very straightforward PPI plus regex's hybrid Perl parser, plus a multiple dispatch mechanism. Because I thought I might want to declare 2 or more keywords that have the same name but different parameter lists. So I might as well throw in a dispatch mechanism as well while I'm here. So, simple. And here it is. Here's the module. You use keyword simple, you use PPI, and in your import subroutine you declare a simple keyword called keyword and a callback for it. What does that keyword do? It immediately parses all of the remaining source using PPI, building you a parse tree, and then it goes through and looks at what do I expect the keyword to have. I expect the keyword to have an identifier, followed by a parameter list, followed by a block of code. So I wrote a little extractor that extracts that from the source code. And that's the hybrid PPI and regex parser, which if I had an extra hour, I would actually show you. But, I like you, so I'm not going to. What do you get back from that? You get back the name, you get back the parameter list, you get back the block, and you get back the rest of the source code. So what do you do then? You just build an implementation for this new keyword. And I am going to show you that in a minute, but not quite yet. So you build the implementation for this new keyword, which of course is just a parser for that new keyword. And then you build the source code that's going to replace the keyword. And that's just a begin block, because you want it to happen at compile time. And what does that begin block do? It declares another keyword with whatever name you gave it and whatever implementation you gave it, attaches the trailing source code, puts it back into the original source, and that's how it works. Plus about 1,000 lines to implement that very simple parser. So then you have this new keyword, and what does it do? It takes the various components that you give it, the name of the keyword and the parameter types and the values and the block of code, and it basically just rearranges them into a begin block. And that begin block says, I'm going to declare whatever debug keyword you asked me to declare. First thing I'm going to do is parse the source code after the debug keyword. I'm going to run it through that same extract arguments with whatever parameters you told me it's supposed to have. I'm going to pass that into a subroutine which has the parameters that you expected your keyword to have. I'm going to use the body that you gave me as the body of that subroutine. It's going to return the new source code, which I'm just going to append to the existing source code and put back in the existing source code. And then that will mean that now when we have the debug keyword, we now have a debug keyword that will just rearrange that into whatever you said the source code for the debug keyword was. And having written that tool, I immediately re-implemented DOS. I took my implementation with all of the unnecessary infrastructure code, and I just got rid of the unnecessary infrastructure code and increased the font size. This is my infallible metric for better code. If you can increase the font size, the code is better. And then I just said, well, I'm going to now use keyword declare. I set up a couple of compile time regexes for types of things that I want to match. And I make a keyword. The keyword says, I'm going to take now these arguments and I'm going to return the source code for the method. And the arguments are just, I'm expecting a name, I'm expecting a list, I'm expecting some attributes, and I'm expecting a block. The name and the attributes are just these regexes that I set up at compile time. So you can declare your keyword parameters either with standard Perl types or with regexes that you just wrote. And the other ones, like list and block, are just shorthands for saying PPI structure list and PPI structure block. So in other words, what the extractor does is it says, well, if you said to match a regex, I'll match a regex. If you said to extract something using PPI, I'll extract it using PPI. And if you think it wasn't fun coordinating those two, so it dumps the parts that you asked it to parse into these variables, which can be optional. So you can say, okay, there won't be a parameter list or there won't be any attributes. And then we just do what we did before, which was convert the code to standard Perl code, and we return the new definition of the method. And that's it. Which means to write my other keywords, I just had to do this. And now the whole thing fits on one page. And that's my definition of success. So with that tool, my Perl 5 classes became just as pretty as my Perl 6 classes. You say use Dios, you now have the keywords, and it all works beautifully. And so this would have been a relatively short talk if that had gone just that well. But it didn't. In fact, everything fell apart in just 1 second. Because my test suites were all running beautifully, it all seemed to go really, really well, and then I built my first real OO app with the module. That was fine, that was really easy, it was really quick. And then I ran my first real OO app. And 950 milliseconds later, the damn thing started running. Yep, took just under an entire second to compile. So, being a cautious type, I doubled the number of classes, methods, and attributes, and now it took just over 2 seconds to compile. So the slowdown wasn't even linear. Hulk said. So what was the problem? Why was it so slow? Well, it wasn't at the Dios level, it was down a level at the keyword declare level. And keyword declare was struggling to do this with good performance, and the reason is simply because Adam Kennedy hates me. Really hates me.
But it makes Perl 6 look fast.
Yes, indeed, it did make Perl 6 look fast. The problem is here. The problem is that the PPI module, while it is brilliant and very fast for doing the impossible job that it does, is not absolutely very fast. And it's not absolutely very fast for a very reasonable reason, which is when you run one of these keywords, it gives you the rest of the file that you're supposed to extract the stuff from, and you give that to PPI, and PPI goes and parses all of that source code and makes an enormous tree of which you want maybe 2 or 3 of the first elements. And then when my keyword declare builds you a keyword, what does it do? It uses PPI to do the same thing again. So I'm not just parsing the entire rest of the source code once, I'm doing it every time I declare a keyword and every time I use a keyword. And I'm re-parsing the entire rest of the file, which you can immediately see is an n-squared operation. So every time I declare or use a keyword, it re-parses the entire source code. Now, that's not keyword simple's fault because it's following the API for pluggable keywords. It's not even PPI's fault because PPI is doing the job it was designed to do. It's just an impedance match. The keywords just want specific arguments. But PPI only parses general code. PPI parses what you actually give it, and you can't direct that. You can't say, look, don't bother parsing if this is not a block. So there's my problem. I'm left with, I have to parse everything and then work out whether it was the right stuff. In other words, it's the old marine dictum, parse everything and let Dios sort them out. So obviously I needed a different approach. I needed some way of parsing Perl code so I'm only parsing the bits that the keyword has pre-declared that it's expecting. So that it quits if there's anything else. Kind of like a regex does. You know when you write a regex, you say, I want you to parse this, and then parse this, and then parse this. And if you fail in any one of those tasks, it just stops. It doesn't bother to parse the rest of the entire string and then just say, oh, I failed at the first bit. Like a regex does. I realised that all I needed to do was create one new module, which would be a partial PPI replacement, or a pure Perl recognizer, or, let's be honest, a Perl parsing regex. So the name is going to be obvious right from the start. PPR. You use PPR, and it gives you a single variable called PPR grammar. And this variable declares regex components, independent subpatterns, which collectively parse Perl. So then you can use those to parse identifiers and variables and expressions and optional white space and anything else that you need to. So you can use it to parse the arguments to a method, for example. But of course, parsing them is not what you want to do. You want to extract them. And how do you do that? In the way that we do it with all regexes, you simply capture the bits that you're interested in and unpack them into your variables. And it's not just for my three little words. You could do it for anything. You could say, I want to parse a new try, catch, finally construct, each of which has a block. Or you could do this. You could say, I'm going to parse any Perl use statement that I find in my source code, and I'm going to capture it, and I'm going to do that with a global match, so I'm going to match all of them and get back a list, and then I'm going to grep out all the undefined elements, which would be the internal captures that didn't capture anything, and that will be a list of all the modules that that source code is using. But how, you ask, can this possibly work? Well, it turns out the entire module only required 4 statements. I'm astonished that no one has done this before when it's so simple. You declare the package, you set up your version information, you use UTF-8 because of course the source code that you wanted to parse might be using UTF-8 and you have to deal with that. And then you very simply write a single statement that assigns this regex to the PPR grammar variable. And then you just write a regex that matches Perl. Would you like to see it? So, it's all in the big define because it's not actually going to do any matching itself. You have to tell it which of these to match. Then you have a series of named captures which represent these independent subpatterns that you can call with the ampersand construct. and you have one that matches a document and one that matches a statement. That's not coming out as well as I'd hoped. So, it's 1196 lines long, about 36,000 characters. It has 80 separate independent subrules, and for some reason, one gravitational singularity down the bottom. I'm not sure why, but it doesn't work when you take that out. It declares rules that you can use for everything. A whole document, a statement, a return statement, a term, a format, a block, parenthesis list, anonymous arrays, literals, quote likes, here docs, regexes, bare words, all the way down to pod and optional and necessary white space. Now the thing I'm going to tell you, which you're not going to believe, but it's absolutely true, is it turns out that it's not actually all that difficult to write an 1196 line regex. What turns out to be difficult is to debug the damn thing. It's really easy to write one that's wrong, but I thought to myself, that's not going to be a problem because I've already solved that. And how did I solve it? With an extra level of indirection. You may be familiar with a module I wrote called regex debugger. People heard of that? Yep. So, regex debugger, I think, is a useful module. And so when I started having difficulties with this small 1196 line regex, I thought, oh, just fire up regex debugger. At which point I discovered that regex debugger couldn't actually debug patterns that had been interpolated from a QR, which kind of made it difficult. Also, unexpectedly, it struggled with large regular expressions. You'd have thought everyone was using it from big ones. And one of the main reasons that it struggled was because the original version of it only had step-by-step-by-step execution. And when you've got like 100,000 steps, that's not a very optimal solution. So before I could do anything else, I had to fix this. And the new one does handle interpolated QRs, and more importantly, it now has step over as well as step into. So you don't have to dive down into the 80 layers of subrules when you know that they're going to be okay. And more importantly, you can also return from a subrule at any point. So it's basically like the Perl debugger now. There are all kinds of other improvements that I made to it, but it took the debugging process from from being near impossible to being absolutely trivial. So let me quickly just show you, where are we? So here's that simple example of trying to match something, and we say, well, can we match it? Yeah, we can, because there is in fact a try followed by a code block. What's it actually doing? You say use regex debugger, run the same thing again, and now it shows you the entire regex and it shows you the string, and you can walk along and say, okay, I'm going to try this, yeah, that matches that, and now I'm going to try optional white space. Do I really want to look inside that? No, I don't really want to look inside that, so I just next over it. It goes away and does all the matching for it and says, yes, it matched, and then I step again. Do I want to look inside the Perl block? Yes, I do. So I jump down and now I'm inside the Perl block. Do I want to step through that? No, I want to step over it, and so on and so forth. And this makes it relatively easy to debug regexes of any kind of complexity that you like. So if nothing else in this talk is useful to you, give that a try. Now, of course, at this point, I realised the magnitude of my folly. At this point, I realised that in order to create my has keyword, I had to descend through 5 levels of indirection to get there. I was more or less in the script of Inception. Except it was Perlception. So having done that, having upgraded regex debugger, and I gloss over the 6 months that took, it was now simple to implement a regex that matches Perl. And you're saying, oh, well, okay, Damian, but does it really? And the answer is yes, at least as well as PPI does, which is surprisingly well. And more importantly, it does it 5 times faster than PPI, because it's just using regexes. Now, I have to put an asterisk on that, because of course it's not doing the same job as PPI. All it's doing is saying, yep, that's Perl, and maybe extracting bits of it for you. It's not building you a whole parse tree. If you want a whole parse tree, PPI is your module. But for just recognizing and extracting chunks of Perl, PPR is the one. It passes the entire PPI test suite. It was really convenient to have a good test suite already in place. But PPI's test suite, while good, wasn't really sufficient, so it also passes its own test suite with this many tests. It parses every one of the 1,370 modules that I've ever put on CPAN. It also parses the 3,500 other CPAN modules that I happen to have downloaded on my system, as you do. Well, as you see, I've had Moose on my system, so... And just for the hell of it, I put that in one 57 megabyte test file. And you're saying, well, that's great, Damian, so it handles regular Perl, but what about the hard stuff? What about the interesting stuff? Well, obviously, first of all, it parses its own source code, and PPI's source code, but it also parses the really cool stuff. Eridal's magnificent camel code, it parses perfectly. And Blockhead's answer to the camel code, which was the operatorless Jaff, parses that correctly. It'll parse anything that Acme eyedrops will convert to Perl code. And it will also parse code written with my very favourite module in the entire world, Karen Etheridge's Acme look of disapproval. Is that not the most beautiful thing you've ever seen? And of course, for the ultimate test, yes, it does parse self-goal. Now, when you're writing a regex that parses Perl, you actually learn quite a lot. I thought I'd want to share some of that with you. The first thing you learn is you really shouldn't be implementing a regex that parses Perl. But I learned that far too late. What I did learn was that insufficient greed is not good. When I first wrote the module and got it to work, you should have seen the happy dance. It was just a joy. But it didn't work very, very fast. It was only very slightly quicker than PPI, which was not going to help me at all. And I'm thinking, what the heck have I done wrong? It's a regex. And what I realised was all the slowness was in the backtracking. If you say, I want to match one or more things in a list, then when you fail, it goes back and matches one less thing and tries again, and then one less thing and tries again. So I needed it not to do that. Unfortunately, Perl 5 regexes have a lovely mechanism that allows you to say, try and match this, and if you don't, or if you do, and then you backtrack, don't undo it. And that is with non-backtracking groups and loops. So basically I went through all 1,100 lines and put just about everything in a non-backtracking group or loop. In fact, there are only 2 places in the entire grammar where you need backtracking, which frankly astonished me, given the ambiguities of Perl syntax. But you're only 2 places that you needed it, and this increased the speed by a factor of 4. Basically because it was converting a non-deterministic finite state automaton into a deterministic one. And I had to do that in all kinds of places, and another way that I had to do it actually takes us back to the gravitational anomaly. If I zoom in on that a little bit, you'll see that what that is the part of the regex that matches any built-in Perl keyword. But it does it in the ugliest way imaginable. It matches it one character at a time, rather than having to match all of the keywords and backtrack when all they fail. Now, even I am not crazy enough to write that out by hand. There's a lovely module that will do it for you. Dan Kagai wrote a module called Regex Optimizer. So you just write the dumb, slow version of it, and then you tell it, hey, optimize this. And it produces that lovely thing, which I then just cut and pasted straight in. But you also learn a lot about Perl when you're creating one of these regexes. And I would have bet that I knew pretty much all of Perl. And I was so wrong. It was a great lesson in humility for me, which I obviously need. I was familiar with this construct. And you're probably familiar with the fact that you can and should put a my declarator in there to make that a lexical variable guaranteed. But were you aware that you're also allowed to put an hour in there, if you want to be crazy? And if you really want to get to the edge, you can even put a state in there. Yep. And if you've got 522 or later, you can do even weirder things. You can put a reference to a variable in there. And this hooks it in to the new Perl feature where you can do aliasing by assigning to a reference. And it's not interesting to do it with a scalar, but it is really interesting to do it with an array. So if you've got an array of nested anonymous arrays, then each time you go through, you're going to get an anonymous array. And if you put a backslash there and declare your iterator variable to be an array, it will alias that array to each of your nested arrays in turn. And then you can just operate directly on the array. That is enormously cool if you have 522 and later. And it works for hour, and it works for my. And if you have 526, they even got the syntax right. And it works for hour, and it works for state as well. And yeah, PPR handles all of them. If you've done any object-oriented coding in Perl 5, you're probably familiar with autoload and or destroy. This is your generic method, the fallback method if you don't find a method in the class, and the destructor method. But did you realise that for those two particular methods, the sub keyword is optional? Yeah, and 3 people in the room are nodding their heads. PPR handles that as well. Oh, it's better than that. For the other things that are made of capitalised keywords and blocks, the sub is optional in the opposite direction. I don't know what genius thought that up. But that to me screams job security. I'm writing the part of the regex that matches statements, and I can't believe I forgot the most obvious statement that you want to be able to match. That one. So I fixed that. On the CPAN now it works fine. But then I realised that this one also has to work. Ugh. That, of course, is a labelled empty statement. And yeah, normally you use a better label than that. But you do have to be careful because you can't just choose any label for that. Yeah, that's not a valid statement because that's not a label. It's the start of a regex with weird delimiters. And boy, did I have fun trying to parse regexes with a regex. Because you come across something like this. Is that valid? Well, it is if you put a semicolon after it. That's a regex match against the invisible $_ variable, and the result of which being passed to the foo subroutine. And if you use it in any kind of expression, it is as well, or if you use it with a quantifier after it, it is as well. But now it isn't. And your thing is, no, now it's 2 divisions. Nope. Not 2 divisions either. Syntax error. You want 2 divisions, you actually have to put the parens in there. And yeah, PPR gets all of that right as well. And everything in my regex was going so very well, and then I had to handle here docs. You know, a here doc, you're running along in an expression, you're parsing the expression, you come across the here doc introducer, you work out what the terminator is, and then you just match everything to the terminator. And you say, well, how hard could that be? That's not hard. What's hard is the fact that you can stack here docs together. And now to parse this, you basically have to come along, find your first terminator, skip ahead and parse that out, and then skip back and keep parsing, and then skip ahead and parse that out, and then skip back, and then go forward, and then jump over the whole damn thing, and regexes don't want to do that. They really, really don't want to do that. Telling a regex, oh, just skip ahead and then come back, the regex says, no way, man. So what do I end up having to do instead? What I end up having to do instead is I had to give my regex some memory. I had to say, okay, parse this, encounter one of these and say, okay, I've got to remember at some point to parse that here doc. And then I continue on and I'm parsing the rest of the thing and I've got to remember. So I didn't just need memory, I needed a stack. Technically a queue I needed. And then I continue parsing, and other statements I have to parse until I get to the first new line. And then that first new line can't just parse a new line, it has to look at the queue of things and parse all of them as well, and then continue on. So you end up with a subroutine that looks like this. You parse your here doc introducer, you parse the new indented here doc marker. If you haven't heard about the indented here doc marker, you want to see Sawyer's talk, because that's very cool. You parse your here doc terminator, which can be an identifier or anything in any of the standard kinds of quotes, or just to make life really impossible, nothing at all. And then you work out whether you already have memory for this. Have I already seen this before? Because there's no point in remembering it again. If not, you set up your memory for it, and then you say, well, is there anything pending? You know, do I need to look ahead here somehow? And you work out what you're going to do. You parse ahead, look ahead, everything up to the end of the line, and remember where we parked. And then everything that you've already had to parse with previous here docs, and then the new here doc, and then remember what you're going to have to skip eventually when you actually parse this damn thing. Remember, this is all in a look ahead, so you're not actually parsing it. Remember where we parked, and then match everything to that point. And then you have to find every other place in your regex that ever matches a new line and change it. If there's nothing waiting to be skipped, then you do optimized matching of white space and comments and end markers. But if there is something waiting to be skipped, then you do as optimized matching as you can do. But if you have to match a new line, then you also have to skip after everything after the new line, up to where you remembered you have to skip to. And then you have to do that everywhere else in the regex that matches a new line. Inside every quote like, and just for fun, also inside every format. This one was the killer. Because it turns out that you can intertwine formats and here docs. You do a here doc, then you do a format, and then you go insane. So, to sum up, you really shouldn't be implementing a Perl parser in regexes. But having successfully implemented a Perl parser in regexes, I could now re-implement my keyword declare. Isn't that the great thing about Inception? You forget that you're in the dream. And then we play the music and you wake up. So I got rid of all the PPI stuff and replaced it with PPR stuff. And the PPR stuff just says, match against a regex that's going to match any keyword declaration. Or if it fails, tell me that ain't a good keyword. And the regex is going to use named captures, so to do the unpacking, I just unpack the named capture variable into sensibly named things, which I can then use in the same code as before. What does that regex look like? It's not even really complicated. It just uses the PPR grammar and the various rules that that provides to create name, parameter, and block and capture them as named captures, which I then unpack from that variable and then use to create the new keyword. And everything above that level is exactly the same as before. But now the parsing is based on regexes, so you can direct it so it's efficient. It now only ever parses up to the first unexpected part of the trailing code or to the last expected part of the trailing code, and it never needs to parse to the end of the file unless your keyword is at the end of the file. And it turns out to be about 10 times faster for doing this on short source code files, and it gets even quicker as they get longer because it's doing less comparatively. Exactly the same API before, so I didn't have to change DOS, the next level up. And where it was previously taking a whole second to compile, now it was doing it in just on 100 milliseconds. So instead of beautiful Perl 6 and ugly Perl 5, both of them are equally beautiful. But now Perl 5 has the power of Thor. So at last, at the top level of everything, I had my 3 little words. Here's the moose version of it. You declare the moose class for a person. You declare the moose class for a user. You write your code and it prints out the date. This is actually from the moose examples. You do it in DOS. You declare your class for the person. You declare your class for the user. It now all fits on one page and runs faster. But you know what? Not only did I have this problem solved finally, I had so much more. Because in my 5-level inception, the dream had been made real. Because I had now given myself the power to warp the Perl 5 universe in any way that I wanted to add any kind of keyword that I needed to. So not just for DOS, the next level down I had keyword declare, and I could make any keyword that I could think of. So naturally my response was simply, well, okay, fair enough. I created a module that said, I don't just want the keywords from Perl 6 for objects, I want all the lovely control structures that Perl 6 has and Perl 5 doesn't. So I want that really nice infinite loop structure where you just write loop. And I wanted a repeat while that Perl 6 has. and I wanted a for loop where you could iterate 2 variables at a time, like Perl 6 lets you do, which is fantastic for iterating hashes. And I wanted first and last blocks within a loop which would only execute the first time through or the last time through, which is sensational for putting delimiters around anything that you want to print out, if there's anything to print out. And yep, all of that just works. And when you don't have a match, it doesn't even print the delimiters. Why? Because it didn't go in the loop. And so if you're going to have all of the control structures of Perl 6, then why wouldn't you have try and catch as well? So the module provides try and catch as well. And as you saw, I did a lot of testing for this module. I love the test-driven development. I love the test frameworks that are available in Perl 5. But I don't love having to remember everything that test more gives me. Do I want is? Do I want okay? Do I want comp equals? Do I want is deeply? I just like to say okay for everything and let Perl sort it out. Because that's the kind of deep thinker I am. So I wrote a module called test expression that makes an OK keyword. And what does it do? It evaluates the test that you are doing, extracts from that the various variables involved, builds the test properly using test more underneath, and if there's an error, it gives you the best error messages in the whole world. We failed this test. That was false because X was this and N was that. And that saves me so much time. You just write every test as a comparison using the smart match operator if you want is deeply or anything like that, and it just does the thing for you. And then I thought, why shouldn't we have the benefits of Java in Perl 5 as well? Sigils, another idea that we can argue whether it was a good idea or not. But now you have Java, and you can create variables and localized lets and constants, and you can give them types, and then you can just use them without those nasty sigils that you can never remember anymore. And it runs perfectly well, except, you can't assign to a constant. So let's go and make that a variable. And we can't assign to Fred because it's of type it's of type num, so let's get rid of the typing there, and it all just works. And then I thought, you know what we're missing? We've got my and our, but we don't have your. Obviously. So I created a your keyword that declares a variable, and that variable tracks itself. Every time you assign to this variable, it prints something out to tell you, my value changed. This is really handy for debugging. And it just prints it out with the line number and what the variable was and all the rest of it. And if you kind of like that thing, but you don't want to use a scary Damian module to do it, there's another scary Damian module to do it. Like everyone else on the planet, I've written my own data dumper module. This is called data dx, and you get a dx keyword where you give it the variable or you give it some arbitrary expression, and because it's a keyword, it has that thing, so when it prints out the message, it prints out the variable name or the entire expression for you, and when you dump the thing out, it just dumps it out with all of the useful information there. And of course, those of you from the medical side of the world will know that that's not how you actually spell dx. It's d sub x. So of course, that works as well. As long as you turn on UTF-8, then d sub x also works. Because I wrote PPR so it can handle UTF-8 as well. And then I thought, why should I restrict myself to Perl 5? In a for loop, you often want to do something expensive, so I'm going to write that in C. So I made an ANSI C block where you could just write that bit of the code in C. And then I thought, well, what if I need something like greatest common divisor? Well, I've got a good algorithm for that in Python. So I made a Python block that allows you to just put Python code in there. And if I need to check if things are prime numbers, well, I know how to do that in Latin. So I created a Python block and I created a Latin block. And you run that and it just does all the operations. Now, that wasn't anything very clever. All I did was put keyword wrappers around inline C and inline Python and lingua romana per legato. Simple. And then I wrote something that might actually be useful to people. So I wrote this piece of code which uses the PPR grammar in a whole series of places to do this for you. Here's a bit of code. It's just regular kind of procedural code. It's nothing very special. It's a bit ugly, and it's ugly enough that I'd kind of like to be able to refactor it out. All it does is take some values, manipulate them, sort them, get the corresponding values out of a hash, and then I just print them out. So I thought it'd be really nice if there was some easy way of factoring that out so that I don't have to look at that ugly code anymore. So I wrote this little tool that allows me to select the code that I'm interested in and just say refactor that. And it says, well, what do you want to call that? Well, I'm going to call that HM sort. And it says, okay, but if I'm going to create a subroutine called HM sort, what's it going to return? Well, it better return maybe one of these values, but which one? Well, let's just do keyword completion and see. Let's just go with heat map. And it replaces the code with a call to that function and all the parameters that it would need to do its job. And then all you have to do is insert the actual function that it wrote for you. And of course now I'm going to have to say for that. And it runs exactly the same as before. And if you are clever and want to use functional style code instead, then it's even better. You can just select the horrible bit of your functional code. You can say, refactor that for me. Again, we'll call it HM sort. And it doesn't even ask you what to return because it can work that out with functional code. So it just inserts that there for you. It doesn't get the line up quite right. That's Vim's fault. You insert the function again and it still runs. And pretty much all of that I'm achieving with keyword declare, which is built on top of PPR, which is built with the considerable assistance of regex debugger, and with which I built DOS and Perl 6 controls and test expression and data DX. And every one of those is on CPAN now, ready to go. So my hope is that with these tools and meta tools and meta tools and meta tools, that you are now going to be able to go out there and steal stuff from Perl 6 yourself. And steal from C and from Python and from JavaScript and from Haskell and from the Roman Empire. And that will help you to love Perl 5 exponentially more. So thank you very, very much. Thank you.